meditation, neuroscience, and consciousness. So yesterday we heard from Swami Sarvapariyananda on consciousness from Vedantic perspective. That is, he spoke about consciousness from both Advaita and also Sankhya perspective. So today we will hear about consciousness from the neuroscience point of view. So according to the Sankhya and the Vedantic perspective, consciousness and mind are different. Whereas from the neuroscience point of view, when we talk about consciousness, it's mostly about the experience, subjective experience of self. And there is a hypothesis that brain generates consciousness. And is it so, or is it not? So these kind of questions need answers, and I think this symposium will provide some answers for these questions. So we have a highly distinguished panel today to address these questions and also talk about the relation between meditation, neuroscience, and consciousness. Like, does meditation help enhance one's ability so that one can access this consciousness, or what is the relation between these three things? So today, to chair this session, we have Dr. Bindu M. Kutty, who is the officer in charge and also professor at the Department of Neurophysiology. So I request Bindu ma'am to chair the session.
A very good morning and a warm welcome to you all to this session on meditation, neuroscience, and consciousness. And Sagar has given a very beautiful prelude on this about this particular session. And we have got eminent speakers in this session. So now, without wasting much time, we will directly now start the session. So the session goes like this. I will be inviting the speakers, and I will also reading out their short CV for the participants to know about them, about the speakers. And each speaker will be given 25 to 30 minutes. And at the end of the session, the whole symposium, we will take up the question answers and we will have some discussion. So this is the way it goes. So our first speaker in this session is Antonino joined? No. So the first speaker is in this session is Dr. Arnaud Delhomme, and he's a good friend of ours. And it gives me great pleasure to welcome him to deliver the talk. And before he starts his talk, I would like to read out his very elegant CV. Dr. Arnaud Delhomme is a distinguished neuroscientist and developer of EEG Lab, one of the most widely used softwares in EEG research. He is currently a research scientist at the Schwartz Center for Computational Neuroscience at the University of California, San Diego, USA, at the Paul Sabatier University, France, and at the Institute of Nautic Science, USA. He is also a consulting scientist for companies such as Philips Neuros, EEG Works, Quasar USA, Neurosync, etc. He has more than 104 publications with a whopping 27,000 citations. In 2006, he was awarded INT 10-year anniversary Young Investigator Award for his exceptional contribution to the field of electroencephalography and encephalography research. It's my pleasure to invite Dr. Arnaud. And on behalf of the CCS, I welcome Dr. Arnaud, and now I invite him to deliver this talk. A very interesting title is Consciousness Within the Brain, Insights from Meditation Studies. Over to Dr. Arnaud.
Thank you. Thank you so much for your kind introduction. So I'm going to share my screen and get started. And I'll get into is consciousness in the brain at the very end. And I'm going to show some of my studies on meditation and consciousness I've been doing over the past 15 years. And so it starts, what is consciousness? So you have William James, but probably a lot of you heard about. He was a professor in Harvard at the beginning of the century, 19th century. And And he said, consciousness is in constant change. Now we're seeing, now hearing, now reasoning, now willing, now recollecting, now expecting, now loving. In hundreds other ways, we know our mind to be alternately engaged. And what's interesting is that his definition of consciousness is actually very close to what Mystic says in India and elsewhere. For example, you have Hamalawa Tasa, sorry for mispronouncing his name. There is no self-as-standard mentality to which characteristics and event accrue and from which they fall away, leaving intact at death. The stream of consciousness flowing through many lives is as changing as the stream of water. So that's my interest, is the stream of consciousness and the stream of consciousness during meditation. And during meditation, what happens is that you experience a lot of mind wandering. So you think about other things. So I'm going to structure my presentation here through some research we've done. And the first one is about mind wandering during meditation. So what is mind wandering? Well, when you're sitting and meditating, you might start to think about something else. So it doesn't only happen during meditation, it can happen in many other occupations like you're reading, but it specifically you become aware of it and when you start meditating, because most often you try to just focus on your breath and you start thinking about other things. That's something that's very familiar for meditators. So we did this meditation where we asked people count your breath from 1 to 10. And when you arrive at 10, you start at 1 again. So 1, 2, 3, etc. And then they're going to start to think about other things. So they're going to start mind wandering. And we ask them to press a button whenever they realize they were mind wandering. And then they had to start meditating again. And we wanted to understand what happens in the brain. So we recorded their brain waves and we studied their brain wave when they were transitioning from being distracted to coming back to their meditation. And to do that, we used EEG, so brainwave analysis. So here, there is a subject, and we record the time series. So these are the wiggly line right here. And based on these time series, we can extract spectral power, so brainwave amplitude at different frequencies, and we represent them in this way. So this is a schematic head. You have the ears here, the nose in the front, and basically when it's red, it means high amplitude brainwaves, and when it's blue, it means low amplitude brainwave. And we can also project it on the head of the subject if we have a 3D scan, and visualize these brainwaves on the head of the subject instead of in 2D. Or even we can also try to find where it happens inside the brain. And so basically this is what we found. So we looked at the brain waves 10 seconds before and 10 seconds after they were refocusing. And we found all these changes. We found this change that in these different frequency bands, delta, theta, alpha, and beta. And one of the most prominent change was in the theta frequency band, so that's about 5 hertz. And what we found is that you had a lot of amplitude in these frequency bands, and especially in these brain regions, so in the occipital region. And then when the person started refocusing, it disappeared. We also found some differences. We also found some differences in alpha, with some increase in amplitude here after refocusing. So we have some inversion here that's very interesting. And so we interpreted that with respect to literature, but we also were interested in determining, well, is this specific to this meditation tradition, or is it different in meditation tradition? So this comes to our second paper, which I'm going to talk about here, where we did this experiment in India. The first experiments were done in France, in our laboratory in France. This experiment was done in India, in Rishikesh. And what happens is that Swami Veda Bharati bought an expensive EEG system and then invited us to use it. And I'm here, you can see Ravindra Patashiti here, which is one of the organizers of the conference. This picture was taken about 20 years ago. And so we were recording the EEG in bungalows, in these small houses here, and this is a subject being recorded during meditation. And in this project, we're recording and trying different types of meditation, especially along the spectrum of focused versus unfocused attention. So on focused attention, we have the Himalaya traditions, and unfocused attention with the Isha tradition with Sadhguru, and in the middle we have Vipassana. So this kind of spread around the spectrum, you know, we can discuss it, but that's the way we structured it. And we looked at people when they were mind wandering compared to not mind wandering. However, we couldn't find any difference in this because of the methodology we used. Another thing we did is we tried to compare the meditation traditions. And what we found is that when we compare with controls, so we had more than 16 participants here in each of the groups, and they were age and gender matched and education matched. And we saw that all the meditation tradition here seems to be different from the controls, which is kind of good news. It means like whatever meditation you do, you seems to have similar brain changes, at least in these high frequencies. And this is the type of changes we observe in what we call the gamma band. So we see very similar change when we look at the scalp. We had some changes which were specific to some meditation tradition here in Vipassana, but I'm not going to enter the details here. So now we were looking at experienced meditators versus non-experienced meditators. If we don't see difference between tradition, what about experienced versus non-experienced meditators? And especially we're interested in looking at when you're mind wandering, as you get more experience, do you get better or you don't get better? And if you ask people, meditators, they'll tell you, yes, of course you get better. But there is it had never been studied scientifically. So we did this experiment in which we interrupted people meditating, either expert or novice meditators. And again, this experiment was done in India with people who were meditating several hours a day. And we asked them every 2 minutes, 3 questions. Please rate the depth of your meditation, rate the depth of your mind wandering, and how tired you are. And we had 24 subjects, 12 experts and 12 non-experts. And what happens is that we want to compare time regions here, so their brain activity when they're meditating. So when they're answering the question, yes, I was very concentrated. And here they might answer the question, no, I wasn't concentrated. Again, they might answer the question, no, I wasn't concentrated. And here, again, they're in deep meditation. What's interesting with this study is that it's one of the first one where it's purely subjective. We ask them subjective question, and then we go back and look at their brain activity. So here, that's the difference in brain activity in the theta band. So there's the same frequency band that we observed in the first study. So this is reassuring, although the effect tend to go in not the same direction. And so we interpret that in terms of working memory engagement. Also, here, this is more frontal, and the other difference was more occipital. The interpretation of this brain data with respect to the attentional network, etc., is not trivial. In terms of behavior, so this is the experienced practitioner, and we see they spend about 75% of their time meditating and 25 reporting their mind wandering. And for the novice, we had a very different pattern. So this is proof to some extent that the expert meditators here had deeper meditation than the novices. So they were mind wandering less, although we can also argue that these results are because of self-selection, like the novices who just mind wander a lot, they're going to drop meditation. So that's why here we have this difference. But this is, one of the first steps in this direction. We published other papers, review papers on meditation and the wandering mind, or when the meditating mind wanders. So we are we believe we are the expert in mind wandering during meditation. And I'm actually really good at it. I mind wander all the time during my meditations, which is one of the reasons why I wanted to understand that question. The other thing we wanted to do with that is to look at neurofeedback. And so I'm going to explain you how we do neurofeedback. So we published this review, which got a lot of interest from the community, meditation and neurofeedback. How can we couple meditation and neurofeedback? And here we have, we believe is one of the first paper, and maybe the only one, where we have neurofeedback combined with meditation. And the goal is to, so neurofeedback is you look at your brain waves and you try to change your brain waves based on the sound. Basically, you have a sound feedback, and based on the sound, you ask the subject, okay, I want the pitch of the sound to increase, and the pitch is going to be linked with your frontal midline theta, for example, in this case, because it's linked to what we found in the experimental paper on meditation. So the subject is getting into feedback with his own brain waves to change the sound. But the goal here, our goal, is to have neurofeedback assisted meditation. So they're doing their meditation, and we know that the meditation increase frontal midline theta, and so they get some feedback in addition. So it's visual or auditory feedback. In this case, it's visual feedback that helps them go deeper in their meditation. So it's not like neurofeedback replaces meditation. It's just like it assists meditation for them to try to go deeper in their meditation. So this is how we did it. So we had several subjects. They were doing 8 neurofeedback sessions. We recorded their MRI before and also after to try to look for change in cortical thickness, because it's been shown there's change in cortical thickness for meditators. We haven't analyzed that data yet. And we also had some tasks before and after. So I'm going to show you that. This is the subject doing the task. Basically, you see is looking at a screen, and the color of the square changes based on his brain waves. And he's going to do that. So he has to do that every day, basically for 2 weeks. And then we see the changes in his attention, etc. So this is just, so we got 24 subjects. Also, we run the experiment double blind. So that means that half of the subjects were controls, and they didn't get real neurofeedback. They got fake neurofeedback. So they got the feedback from other participants who got real neurofeedback. And that's really necessary in this kind of task, because the fact of coming to the lab, of doing all these experiments, people just get better just because they think they're going to get better. So we wanted everybody, even the control, to have the same experience. Everybody thought they were doing the real neurofeedback. We asked subjects. Nobody knew they were getting the brainwaves from other people. And so that's what we found over the sessions, so 8 sessions. And we see here that the actual people we got neurofeedback are able to increase their frontal midline theta, which is what we asked them to do. And the ones we didn't increase their frontal midline theta. Also on the task, so we tested them for mind wandering and other kinds of memory tasks. We didn't find differences in the mind wandering task. However, we find some differences in the memory task in the neurofeedback group compared to the sham group. Basically, they were faster during the cognitive task. So this is a 2-back task, but some of you might know it's a kind of memory task, and they're getting better if they had the neurofeedback compared to the sham. With the sham actually got worse. And now I want to move on to another part of my research. So I'm going to present you that briefly. And this is linked to the claim of some meditators. Here, for example, you have Mathieu Ricard, which is the translator, French translator for the Dalai Lama. He's also Tibetan monk, and he also has a PhD in neurochemistry. And he was at this conference. So this is the Denver conference, first international symposium for contemplative research. And there's the link on YouTube here. And it's relatively fine. You type Mathieu Ricard and this conference. And then in this presentation, which unfortunately I don't have time to play because it's a couple of minutes, but he tells this story of going to meet his teacher, and then his teacher telling him, you were just thinking about that right now. So it's a story of him when he's during his meditation, he's reflecting on his youth, and he was killing a rat because his father asked him to, and he was reflecting on that. And then the teacher, was never heard anything about his life, tells him exactly that, and just asked these neuroscientists. Here you have a Wolf Singer, who's like one of the most eminent neuroscientists in the world at the Max Planck Institute. And then here, a philosopher, Evan Thompson, what it means. And of course, they can't say anything because nobody knows, if these phenomena are real, and if they are real, what are the mechanisms? So it's another part, that I was research I was interested in. And of course, you can't do that if you don't have a tenure track position, but I do. So I can try to address these questions. And one of the first things we did is to run surveys with meditators. So what do you experience during meditation? So we run this survey on about 1,100 people, and we ask them a bunch of questions. So they just fill up questionnaires. And then you can see here, so this in blue is this has never happened. So more than half of the meditators during their meditation believe that they had genuine non-physical entities, vision or hearing, or telepathy experience, or a connection with their teacher or guru. So this was fairly common among meditators, and they were convinced this was real, which doesn't mean it's real. It just means it's common in meditators to believe that these phenomena are real. We run these experiments. So these were not in meditators, although these were people who had meditation in their practice, but there are some people who tried to communicate with deceased individuals, and we tested them to assess if the communication was real. And to do that, we just present them pictures, and we ask them, either do you think this person is deceased, or how do you think this person died? And we spend a lot of time choosing the pictures. So here I'm going to show you how we choose the picture. So we had a picture of individual, and then we wrote a software to reframe the pictures. We had another software to determine what was contained in the picture. And then we had 3 raters really going on every categories, what's the age, etc. And then in the end, we end up with 2 pools of pictures. In this case, we wanted to ask people, are these people alive or deceased? So we had 100 photos of people who were alive, and 100 photos of people who were deceased. And there's as many people were smiling as in the alive categories, but not smiling, as many people of different age, as many people wearing glasses, as many people with different race, etc., the resolution of pictures. So we had the 2 sets of pictures as balanced as possible. And then we asked more than 20 subjects who thought they could connect with deceased individual, whether they could do that or not. And the goal of this experiment is to show, well, is consciousness local to the brain, or is it not local to the brain, as Mathieu Ricard in this presentation seems to indicate. And the reason we did it with these people is that it seemed to be like the easiest test possible. Here you can imagine yourself, we put this task online as well. We run it in the lab, but we also had it online. And where you were filling a questionnaire, where you enter your name, your age, how intuitive you think you were, and then you were starting to do the experiment. And basically you see images. So here it's gonna go into loading the images. You see images and you have to press, okay, I think this person is deceased, I think this person is alive, I think this person is deceased, etc. And most often these are pictures from high school. And so people have no clue whether they're deceased or not. And again, we have many people smiling, not smiling, etc. So they can't use subtle cues. And at the end, people get some feedback. So we run this online. We got some results which were slightly significant, not very significant. We just got right above chance. I think it was like 53% of the people we did it online when we had 100 people were significant. Compared to random choice would be 50%. We did it with 12 mediums, so people who claim they can contact with the deceased, and you see the result right here. Basically, there's no reason it should be above the line of 50%. It should be equally distributed below or above the line. We actually have two mediums which have a performance of 49% here. But the fact that they above this line has odds against chance of 1 in 200. So it's very unlikely that this is significant by chance. We repeated this experience with both mediums and non-mediums. It was slightly different because we asked people to determine the cause of death. And here, when we take the median, both the mediums and the non-mediums, again, we got some significant results. What was puzzling here is that the non-medium were actually doing better than the medium. And we have interpretation, if this effect is real, that it can be based on performance anxiety, possibly. We published 3 papers on these experiments, all in mainstream journal. And it's very hard to publish papers in mainstream journal on this topic, but we thought it was important for the scientific community to have direct access to these results and not publish them in obscure journals. So I invite you to look at these papers. And so are we there yet? So no, we're not. So this is my last slide. There's still lots of research to be done. The experiments I showed you, they seem to indicate something is non-local to the brain, but they don't demonstrate it necessarily. Same for the neurofeedback. There's a lot of things we can do with the neurofeedback, more experiment to try to increase the robustness of the effect. And I just want to thank all my collaborators in France, and at the University of San Diego, and at the Institute of Neurosciences. And thank you for your attention.
Video also. So thank you so much, Arno, for that very lucid presentation. And I mean, you know, the consciousness within the brain. You wanted to study this using, you know, very elegantly designed studies like mind wandering, then using neurofeedback. Mind wandering studies as well as neurofeedback, and very interesting studies like intuition test and even telepathy. So what is your take-home message? Anyway, we will have the discussion later. I mean, at the end of the session, we will have the discussion. So it was a very, very interesting topic. And as Saket said already, that, you know, from the perspective of neuroscience, you know, the definition of consciousness may vary from that, what the philosophers really mean. So we will have some more dialogues in this during the discussion time. Thank you so much. Please stay on. We will move on to the next speaker. I just wanted to, I think Arno joined. I mean, Antonino joined. Can I see, just see this? Nitin, we will ask him, then we will come to you, okay?
No problem, yeah.
What else? Huh? He's not there. Good morning, Antonino.
Hello, good morning. Good
Hi.
morning.
Hello, I am not able to see you.
Hi.
Just,
Yes.
yeah, on your, yes, yeah.
Hello,
Good
hello.
morning.
So, good
Very
morning.
good morning. Yeah, see, so we have just completed one talk now. So since you have, mailed us that you have a class, after the session, so do you want to start your talk now, or will you wait for Nitin to finish?
I'm flexible, so I can also talk now if it is convenient.
Okay, Nitin, shall we go ahead with Antonino then?
Sure, no problem.
Okay. Thank you.
Yeah, because you mailed us, we were thinking even we will put you as the first speaker in the session.
Thank you very much.
Yeah. So welcome, Dr. Antonino Rafford, a very good friend of ours. We have been having constant, series of webinars in the past 2 months. Now that is going to be starting now again in October. I think I look forward to attend that webinar. So it is my pleasure to read out his short CV first before I invite him to deliver the talk. So Antonino Raffon completed a master in psychology and a doctorate in cognitive psychology and science at Sapienza University of Rome. He is currently the associate professor at the Department of Psychology of Sapienza University of Rome, Italy, and visiting professor and advisory faculty at Nalanda University, India. He is also director of the Inter-University Center, ICONA, at Sapienza University of Rome, president of Consciousness, Mindfulness and Compassion, CMC International Association, and chief editor of the specialty section on consciousness research of Frontiers in Psychology. He is internationally recognized research is interdisciplinary with a particular focus on cognitive neuroscience of consciousness and meditation. And he himself is a dedicated Sotosan practitioner. It's a pleasure to welcome you, Antonino, to deliver the talk on the neurocognitive matrix of meditation. Very wonderful title. Over to you, Dr. Antonino. I invite you to deliver the talk.
Thank you very much.
Yes, you can take almost 30 minutes to deliver the talk. And if you are present for the session, we will take up the question answer at the end of the session. Of all the speakers, finish their talks, we will take up the session. Question answer session.
Thank you very much, Professor Cutti. I'm really delighted and honored to be invited in this wonderful webinar conference with outstanding contributions. And I do appreciate all the work that has been done by Professor Cutti and collaborators in the outstanding context of NIMHANS and in general Indian culture, spirituality, and the great academic environment of India. So I'm happy to share about this research, theoretical research that we are performing. So I will just share my screen. Oh, excuse me, just the last slide. So. Okay, I'm really grateful to my international collaborators, in particular from the Bulgarian Academy of Sciences, like Professor Ilyana Yordanova, Professor Vasil Kolev, Professor Rumen Kirov, as well as other colleagues like Professor Peter Malinowski from Liverpool John Moores University and Dr. Luca Simeone at Italian CNR. So it's really this work that relates to our empirical research over the years, also including neuroimaging studies, in particular of Theravada Buddhist monks. So let me say something about the remarkable work of Antoine Lutz and collaborators about the phenomenological metrics of meditation and that was proposed in 2015. And the idea was basically that we have a kind of multi-dimensional matrix of meditation that relates to our experiences in meditation, but not only. Also, this matrix can be applied, according to Lutz et al., also to account for phenomena like mind wandering, rumination, addictive craving, and so on. So basically, the idea is to have dimensions like whether the practice of meditation, there is a level of meta-awareness or not, a level of object orientation or not, or whether the practice is not object-oriented, is more open, so to speak, objectless, so to speak, whether there is a certain level of reification or de-reification, but also other dimensions like aperture of the opening of the attentional scope, whether there is clarity or not, whether there is stability of the attentional focus or not, and the level of effort, which is assumed to be reduced when we have more expert or very expert practitioners. So very interesting. So our idea and our work is to then develop a matrix which is on the neurocognitive side, not only on matching this phenomenological matrix or from taking into account a number of components in neurocognitive that can really be at the substrate, the correlate or neural correlate of meditation. So this is based on the model of attentional networks, the theory of executive functions of Miyake and collaborators, the global neuronal workspace model of consciousness, the dissociation between attention and consciousness. Indeed, it is possible to have attention, observe attention, but not consciousness, conscious access, and vice versa. It is possible to observe consciousness without attention being deployed to a particular object. Then there are other aspects like the theory of mental programs in higher level cognition, and the dissociation between a layer of conscious access and another layer of metacognition, of metacognitive awareness. This can be found also in some theories of meditation, for example, like in Tibetan Buddhism theories of meditation. And then there is an interesting definition of mindfulness, which is, by the way, an open area of research by Shapiro et al. So mindfulness includes three aspects: intention, attention, and attitude. All these aspects are brought in our neurocognitive matrix of meditation. And so I don't go into the details, but there is work being done in neuroimaging to show, for example, that there are neural correlates of different phases. In this case, it's a remarkable neuroimaging study by Hasenkamp et al. 2012. So, for example, mind wandering in meditation can be associated to the so-called default mode network. Then there is the awareness that there is a distraction during the meditation, and this has been related in particular to the salience network, anterior insula and anterior cingulate cortex. Then when we reorient the awareness to the object of the meditation, there is this engagement of these areas also of the frontoparietal network, like dorsolateral prefrontal cortex, inferior parietal lobe. And then again, when we sustain the focus, and I would say also the monitoring of this focus, we engage the dorsolateral prefrontal cortex in the central executive network. And this is a cyclic process. And nicely, this was also embedded in a more encompassing view about the meditation process and the brain networks that are involved in the meditation process by our friend Peter Malinowski, who is one of the co-authors of this work on the neurocognitive matrix of meditation. So to give you an example, so when there is focusing on an object in meditation, then there is this sustaining, and there is an implication of also in particular the alerting network, which is an important component of the attentional networks of Posner and collaborations. Then there is mind wandering, then distraction, implication of the default mode network. Then there is a recognition of the mind wandering, then monitoring, activation of the salience network. Then we let go of the distraction, there is disengaging, attentional disengaging, then implication of the executive network. And then we orient or reorient or shift to the focus of the meditation again, and then there is the implication of the orienting network, another important network of the attention network theory. And Peter beautifully says that when we practice meditation, including when we get distracted or thanks to the distraction or the mind wandering, we have the possibility to actually exercise, to strengthen the actual mechanisms of these brain networks that become engaged in meditation. So it's not, we are far from the idea that of failure during meditation, where we get engaged with mind wandering and so on. Of course, what is important is to become aware or meta-aware of this. So, and then, of course, there is this remarkable model of the executive functions that we have brought in our theoretical perspective, which actually, according to which the executive functions, which are crucial for our mentation, top-down cognition, there is shifting when we do, for example, shift from mental operations like plus to minus, from number to letter processing, from local to global. There is updating when we keep track cognitively of some spatial information, tone monitoring, letter memory. There is a famous task, which is the NBAC task, that can be related to this as well. And then, very important, we have also the cognitive, the executive inhibition, like anti-saccade, stop signal, and the well-known Stroop task, for example. And so, when we perform a complex executive task, according to Mayaki and collaborator, we implicate these three main functions. And then the model, the mechanism of mindfulness based on Shapiro, and there are different approaches to defining mindfulness. This consider these three aspects, core aspects: the intention to be mindful, and of course we need also the intention to meditate. We need to keep in mind the executive goal of, for example, focusing on the breath in case of focused attention meditation. And we will talk about this in our neurocognitive matrix in terms of mental programs in the executive system for meditation. And very important, of course, attention. So to, for example, to be attentive to the present moment and rather than mind wander. And of course, depending on the meditation style, this can be done, for example, in a more focused way or in a more open or objectless way. And attitude, very, very important. Attitude that we bring in our meditation practice relates, for example, to acceptance. This is a very important aspect that has been studied. Also very important to modulate, importantly, executive functions, for example. And so attitude of acceptance, non-judgmental attitude, no, according to the famous definition of mindfulness of John Kabat-Zinn. And another aspect that we bring in is the work on the global neuronal workspace of consciousness, in particular by Stanislas Dehaene and collaborators. We, in our group, we have already elaborated, and we have also done some neurocomputational modeling studies about this approach and how this can be relevant for meditation science. And so just to give you an idea about the principles of this approach. So when we are unconscious about, for example, a word that is briefly presented and then masked, so we have this subliminal perception, there is not much broadcast of this activity in the brain. You see, this is more or less limited to some areas, spots in the visual cortex. But when we have access, conscious access, there is this idea of global broadcasting in the brain. For example, when we have a conscious experience of a visible world, you see the huge broadcast in different areas, posterior and anterior of the brain. So this is a kind of a theoretical context that supports our work. And let me show you some examples of our application of this neurocognitive matrix of meditation. Okay, you will see, sorry, a list of components and subcomponents of this matrix. Let me give you an idea. I don't go so much into the details. So look, for example, let's consider focused attention meditation, FAM, that we have seen before. How do we apply it? And how do we characterize in terms of this neurocognitive matrix, this FAM? So first of all, we need to have an intention to meditate and to keep the mental program of this focused attention meditation. And then we have to encode the executive goal or the intention and the mental program for FAM to maintain in this working memory. It's a part that can be considered as a part of the working memory, this intention. And of course, we need to some extent this metacognitive awareness and retrieval of the intention to meditate focused attention meditation. So from time to time, we may even forget. This relates to the phenomenon of goal neglect, which is well known in a study of executive functions. And there are even patients in cognitive neuropsychology that have these problems of goal neglect. Okay, this is related to the intention, which, by the way, excuse me, let me explain. You see in blue some components that mostly relate to the notion of mindfulness. Or all these components that you see in blue can be regarded as actual components that relate to the notion of mindfulness, actually. So, and of course, we need the attentional processes, like the ones in the attentional network theories. So, orienting or reorienting the focus of attention on the meditation object. We need to sustain attention on the meditation object, and this relates to the idea of attentional stability. We need to disengage the attentional and conscious access focus from distractors, as we have seen before, in particular through this inhibition, no? The executive inhibition. And also, as we have seen from Malinowski, we need to be alertness, the function of attentional phasic alertness, which relates to the vividness of our attentional focus. But then, as we said, the attention and conscious access are not the same process. They are related, but they are not the same. We cannot collapse them in one layer. Okay, so as with the global workspace theory, we have this conscious access and also this metacognitive awareness layer of this. For example, let's suppose that we sustain attention on the breath, but we can be more or less conscious of this experience of the breath, depending on how much we have a conscious access of it. For example, of the details of this experience. So this again relates to this vividness, together with the stability of attention, how much vivid we are about this experience of the breath in the present moment, no? And of course, we need to be aware that we actually keep our attention on the meditation object. This relates also to the notion of monitoring, no? That is very important in science of meditation. But also, very important, the vigilance. Sometimes we can be more vigilant, but sometimes we can be even kind of agitated because so we need to prevent two extremes: too much agitated, and then we have tension and many thoughts. But in meditation, we can also be sleepy on the other side. So as in the global neuronal workspace model, it's very important the vigilance for consciousness. We need to keep an appropriate level of vigilance and have, of course, an appropriate monitoring of this. Am I sleepy in this moment? Am I vigilant or too sleepy, too tense, and so on? So this relates also to the mindfulness in the practice. And then, as we said before, we can put a certain level of effort in our practice of meditation, which, as we know from the tradition, should be not too low, not too much. And this can be related to the actual neuronal resources that we allocate to executive, attentional, and conscious access processes. And of course, we need also a kind of monitoring or metacognitive awareness of how much effort we are bringing in the practice. And last, but very important, the attitude that we mentioned before, which especially acceptance. For example, when we are in focused attention meditation, we may become distracted more or less frequently. And then we might become judgmental. Oh, this is an error. I'm not doing well. But this is not what is recommended. The idea is to accept the distraction, be non-judgmental as an attitude, and let go of it. And this actually relates to this acceptance of distraction, no judgment. And also, of course, we need to be aware when these emotional reactions, like judgments, take place in our mind. We need to be mindful of them and, of course, let go of them, regulate them in a way. And this is just the idea of the application of this neurocognitive matrix to focused attention meditation. For time limitations, I don't have the time to go in such detail for other types of meditation, which I'm going quickly to show you. For example, open monitoring meditation, where there is no object orientation on a specific object. There is no, the attention is kept open. And again, we have a breaking down of different components, which actually can map on different networks and systems of the brain. Again, we do this for attentional processes, conscious access, which is here more detailed, because this form of meditation, we become conscious of different contents of the experience. When we have, for example, feeling, when we have not only breaths, for example, but different aspects of the body, including interoception and so on. Again, vigilance and its monitoring, effort and its monitoring. And again, very important, this practice of meditation, which is pretty much related to different components, a large map of the components of mindfulness. We have a lot to observe also as related to our emotional and motivational states, where desire, aversion, very important, judgment, and so on. And so you can see also a list of sub-components related to this aspect. But we can apply this also to loving kindness and compassion meditation, which, as you know, can be of two main forms: more focused, and there we call this focused or referential with an object. For example, you can have the loving kindness to a person that we love, for example, or a neutral person, or even a person with whom we have difficulties, for example. Or we may focus it, for example, on ourselves, kind of self-compassion, self-loving kindness, or to the people in this assembly, for example. And this is called referential. And this is, you can see again, I don't have the time to go into the details and their neural substrates or correlates, but we apply this to the intention. Very important, the motivational processes and states that we engage with this practice, the state of loving kindness or compassion drive, and the monitoring of it. There are also some attentional processes there, which are more focused on the object of the loving kindness, metta, or compassion. What comes to mind right now is beautiful work done by the group of Bindu, Professor Bindu Putti, on also applications, clinical applications of these different practices of meditation, including loving kindness meditation. And then conscious access and its awareness, vigilance again here, executive effort, and again, emotional acceptance. For example, we might have problems to practice this loving kindness with a person with whom we have problems, for example. And then what happens? We notice this, we accept these emotional reactions and so on. And then non-referential compassion and loving kindness meditation. And we have also done some studies on metta with Theravada Buddhist monks with EEG in this respect that are relevant here. And again, you can see a matrix here, and I don't want to take too much time, but it is really, again, the intention. And this time it's non-referential, open. What does it mean? It's a state of compassion, which is not restricted to a particular object, a particular person, a particular being, a particular space. It is really, it is a kind of universal, you might say. It's to any experience, any being, any space, any location, no? And again, there are some differences, and this maps the components in particular, rather than on FAM, on open monitoring meditation. And again, we have gone through these processes and sub-processes. And again, we can do this also with body scan meditation, when the attention, the focus of the meditation, and for this is very important, the updating function of the executive function. So for some time, we keep our attention, let's say that we start our body scan from the feet. We start from apply attention for some time to the feet, or one of the feet, first left, then right, and then we move on from bottom of the body, or we could start from upper part of the body. And then, of course, attitude is important, vigilance, executive effort, and again, all these aspects. And we apply this also, the neurocognitive matrix, also to mantra meditation, where again, in particular with mantra, we have a particular stance of conscious access, where we need to focus on the mantra object, which is often involving language, no? Speech, and then left hemisphere, we know, and then there is this, there are similarities with focused attention meditation, but also differences, because the mantra might open up to more than repeating a sound, no? In Tibetan, Mani Padme Hum, Mani Padme Hum, Mani Padme Hum, there is more, because this relates to Avalokiteshvara, then relates to great compassion, then relates to the components of compassion meditation, the attitude aspect, but also a particular stance of awareness, which might be, for example, non-dual awareness, and so on. And you can see that the flexibility of this matrix to account for all these aspects. And so I thank you very much for your attention.
Thank you so much, Antonino, for that lovely presentation. Such an intense work you and your colleagues have done to come up with this phenomenological matrix of meditation, and testing that with many various traditions of meditation. It's really, it would have taken how many years? More than 20 years?
Yes, it's interesting. Yes, I agree.
Yes.
To condensate, no, research over here.
Yes, that also gives us that happiness that our brain is has got highly evolved mechanisms. We only have to probe that. See, for example, meditation is a very important tool to understand these various.
Beautiful. Yeah, it's very important. Also, not only understanding meditation per se and the consciousness, as you say, Professor Putti, but it is also meditation can be a gateway, no, for our increased understanding of the brain, neuroplasticity, healthy or non
Yes. And the transformation, what is happening to us from a behavioral point of view.
Very important. Cognitive, behavioral, emotional, very important.
Very, very. Thank you for that.
Thank you, Professor. Thank you, Ravindra.
We will, yes, we wish that you stay back.
Thank you. It's reciprocal, and so I wish the best to all of you and to all of India.
Yes, yes. So that the discussion will be very good actually, because there are 4 speakers in the session, and let us see that how the discussion goes on.
Thank you.
Okay, thank you so much. We will move on to the next speaker, Dr. Nidhin Nagaraj. Nidhin Nagaraj, at present, he is Associate Professor, Consciousness Studies Program, National Institute of Advanced Studies, Bangalore. On behalf of CCS, I welcome Dr. Nidhin for today's presentation, and it's nice meeting you. I will, before you start your presentation, I will just read out your CV, short CV for the participants. Dr. Nidhin Nagaraj has a bachelor's degree in electrical and electronic engineering from National Institute of Technology, Karnataka. Master's degree in electrical engineering from Rensselaer Polytechnic Institute, Troy, New York, USA, and PhD from National Institute of Advanced Studies, Bangalore. He has previously worked as a lead scientist at GE Global Research, Bangalore, and an assistant professor at Amrita University, Kollam, that is situated in Kollam, as a visiting faculty at ISER Pune. His research areas include complexity theories of consciousness, causality testing in neuroscience, brain-inspired machine learning. He has co-authored over 25 international journal publications with more than 1,100 citations, over 50 national and international conference paper presentations, and is a co-inventor of 8 US patent applications. He co-edited the volume titled Self, Culture and Consciousness, Interdisciplinary Convergence on Knowing and Being. He is a senior member of IEEE. Over to Dr. Nidhin. So you are going to talk on the ABC, the artificial intelligence, brain and consciousness, the incompatible trinity of the 21st century. Over to you, Nidhin.
Okay.
We look forward to listen to you.
Yeah, namaste and good morning and welcome to all of the participants. So let me share my screen first. Okay. Is this visible?
Yes, yes.
Okay. Yeah, so let me begin first by thanking Professor Bindu Kuti and Dr. Ravindra for giving me this opportunity. It's a very, very well organized webinar for 4 days, and you had a galaxy of extraordinary speakers, neuroscientists, philosophers, physicists, and even monks. And you've been very kind to include me, who is an engineer and who's trained in mathematical modeling. So I'm going to give a sort of a very different picture from what you've heard now. I mean, you heard some very, very good, excellent lectures on meditation and consciousness. I'm going to talk about provocatively titled topic here, ABC, right? AI, brain, consciousness, the incompatible trinity of the 21st century. And I try to hope to give you a viewpoint from a modeling and data perspective. Okay, so let's begin. As you're all aware, we are in the new era of the brain. I mean, there is an era of the brain which was in the 90s, I guess, and now it's the new era of the brain sciences. And we're also in an information age or information revolution, you can say, because all of AI today rests on information technologies, right? I mean, even this webinar is being enabled by advances in information technology, and AI sits on top of that. So we have this AI and brain coming in. And of course, consciousness is the third vertex of this triangle. And I've chosen this, what you can see on the screen here, an impossible triangle. This triangle cannot be actually realized in practice, because I thought that it's a good metaphor for the topic of my, of what I'm going to talk about today. That is that there are problems in all three of them in terms of the linkages. So what I plan to do is I want to take up the, not so much the vertices of the triangle, but the edges of the triangle. So let's begin first with the AI brain edge. Now, if you take any course on data science or machine learning or AI, I mean, there are hundreds and thousands of courses these days, right? Freely available also. This is probably one of the earliest slides you will see in such a course. So they talk about ANNs, artificial neural networks, and they talk about machine learning and deep learning. But what is told is that it is a mimic of the brain. Well, it's not entirely wrong, but I want to show you that it's actually a very bad comparison for various reasons, actually, because comparing with the brain is very tricky. So I'm going to give you two actually charts, actually comparing the brain with the computer and with AI. So first, let's sort of compare mostly, I would say, the hardware and the architectural aspects of brain and computer. Now, notice that in this particular table here, only the items marked in yellow are the ones where the brain does better than the computer. That is in terms of operations per second and in terms of precision, right? Because we now, I mean, computers can really do highly precise operations. Other than these two aspects, in every other aspect, the brain is far superior than the computer. In terms of number of units, we have like 86 billion neurons. I mean, you know all these numbers, I'm sure. But what is very interesting is the fact that there is massive parallel computation which the brain uses. Of course, we do have parallel computation in computers as well, but it's not as much as massive and as distributed as it's in the brain. And more importantly, I think what is amazing is that the brain uses roughly around 2.6 watts. I mean, there's a back of the envelope calculation you can do. So there's a power consumption of 2.6 watts for sort of a resting state thinking activity. Now, for a computer to do anything even close to that, I mean, requires megawatts or even much more than that. So clearly, there's a huge gap between computers and brain. I mean, there's no doubt in this. This is well acknowledged. But let's come to AI, specifically AI, right? Artificial intelligence and pretty much everything that we use today. It's pervaded all of human activity. I mean, even the ones people watching on YouTube now, I'm pretty sure that in the right corner of your YouTube, there will be the suggestions that's based on data analytics, right? So AI is pervaded everywhere. Now, what is interesting, if you compare AI of today, the leading edge, cutting edge AI of today with the brain, you will notice that there's again a huge gap between the two. Today's AI has neurons which are pretty much dumb. I mean, I don't know why they're called neurons, because they're nowhere like the neurons of the brain, because in the brain, the neurons they fire in very complex patterns, periodic, quasi-periodic, randomly looking chaotic patterns. Furthermore, today's AI uses statistical correlations, whereas we know that the brain is, what it does is causal counterfactual reasoning. So it's a very sophisticated reasoning technique which the brain uses. And very interestingly, the kind of noise levels in the brain, the noise and interference in the brain is extremely high. So there is this nice paper in 2015 where they talk about the calculation of the signal to noise ratio. At a thalamic neuron, it's somewhere like around -20 decibels. I mean, it's extremely high amount of noise. Whereas today's AI, it can't really tolerate even a small amount of noise. It just breaks down. The same thing is true with number of samples for training. We know that AI today is very data hungry. It's data hungry and also computationally hungry. It needs lots of data to train, whereas we are able to learn from very less samples. And of course, we are very good at, we may not be very good at in chess or in other games, which a computer can easily beat us, and even in maybe speech recognition or so, but we are good at generalized things. So that means that we can do a whole bunch of tasks, without needing to change our brain, right? Whereas the AI today cannot really do that. There's nothing like artificial general intelligence. It's still a mirage. We still don't know how to do it. And last but not the least, I think you might be surprised to know that what really unites brain and AI today is actually the fact that we really don't know how it works. I mean, of course, we know a little bit. I'm sort of exaggerating here, but largely we don't know how the brain works, and largely we don't know how AI actually works. I mean, AI does fantastically well. We don't know how it works, how it gets the right answer. Why does it fail? Where is the learning happening? So in some sense, the brain and the AI today are united in ignorance, actually. Now, what is the true cost of AI? So this is probably some numbers which I don't know whether you're familiar with these numbers. They're quite staggering numbers. So GPT-3 is actually a neural network ML-based model, which uses internet data to be able to generate text. So it's used for actually for generating poetry, stories, blog reports, and all that. And it claims that it really comes up to like human-like text. It's able to generate that. Now look at the numbers that's needed to do this. 355 years of computing time, huge amount of money required to train, and more importantly, the carbon emission which this particular model will require is equivalent to five cars running for their lifetimes. So it's really not good for it's not sustainable for the globe. And you can compare this carbon footprint with other things, right? For example, a human life in 1 year will generate like 11,000 pounds of carbon dioxide, equivalent of that. Whereas the largest the model, the deep learning model, that the GPT-3 requires like 626,000 pounds of CO2. So clearly, I think this is not sustainable, right? And to get more accuracies, we need to really the cost will go up actually. Okay, so that was the sort of the AI brain link. Let me look at the brain consciousness link, and this is actually the trickiest link or the edge of the triangle. And very quickly, I thought I will very briefly explain to you that we need to use a scientific method here, obviously, right? Which is 3 steps. You observe data either through experiments or just through passive observations. You theorize with various models, competing models, and then finally you have to infer based on you make a model selection. And you infer in order to understand, explain, predict, and control. So this is the essence of the scientific method. Just as a very, very quick example, you can observe the sunrise and the sunset. That's data for you. And then you could have 2 models, right? You could have the geocentric model or the heliocentric model. And which model will you choose? That's the step number 3, you can say, wherein we choose one over the other because it's able to explain better. It's able to explain with new data. And there are other principles, right? That the Occam's razor, right? That it probably uses less number of variables. We don't want too many, we don't want to expand the model, false reliability, reproducibility, internal consistency, and so on and so forth. So this is the classic scientific method. I thought I'll just give a brief on this. Now, the point is, let's actually do this for our experience right now. So I just want all of you to do a contemplative inquiry. It's also a scientific inquiry that we apply these three steps now. So if you look at your experience right now, here and now, it's undeniable that we have these 2 aspects of experience, right? We have the consciousness side of things, the experiencer, that is the something which is experiencing, and there is the object side of things, the contents of experience, typically thoughts, feelings, sensations, and perceptions. So you could define consciousness as the reality that perceives, the reality in myself, which is perceiving the contents of experience. So that's the data for you. Now the question is, what kind of model can you fit, right? There are obviously many different models that you can actually fit. I'll talk about 2 models. These are not the only 2 models. There are several other models which you can actually use to fit the data that we described in step number 1. But I'll talk about 2 models, the matter-centric model and the consciousness-centric model, model M and model C. Now, model M is straightforward. Model M will say that, look, in order to interpret the data of experience, that is the consciousness side of things and the contents of experience, thoughts, feelings, sensations, perceptions, in order to make sense of it, we are going to hypothesize that there is a world of space, time, and matter, inside which there are several bodies, right? Several bodies. And inside those bodies, there are minds. And inside those minds, there may be consciousness, if we accept that there's consciousness, because there are some people who will deny that consciousness as well, but it could be an epiphenomenon. There's one way to look at it. That will be the model M. And this is the mainstream dominant model. And I think the keynote speaker, Dr. Alan Valens, also talked about this in quite detail. I thought I'll make it more pictorial for people to grasp it. Now, model C is just the opposite. Look, we know consciousness from a first person's experience. What if that were universal? That's the largest container here in this diagram here. That's the largest set here. And individual minds are subsets. Individual minds are subsets. And the body is even more, a further subset of the mind, and the world is shared. So in the model M and model C, the difference is that in the model M, the world is shared. In the model C, consciousness is shared. Of course, the world is also shared partially, but consciousness is what is really shared. Now, the question is, what is the difference between these 2 models? The claim that I'm going to make is that both models can explain the data. They can explain the datum of experience. That is the first claim. But the models otherwise differ completely in every other way. For example, as I said earlier, the model M, space-time matter, is fundamental. And brain is actually the most important thing there, because that's the locus of all experience. Whereas in model C, consciousness is fundamental, and the brain and the body are subsets of it. And as I said here, the hierarchy here is that world is a superset of the body, is a superset of the brain, is a superset of the mind in the model M, and that's reversed in the model C. And the claim I'm making is that both of them can explain the data that I gave you. Okay, and that is something that you can take it as homework. That both can explain the data equally well. Now, if you think about it, right, the question you might ask now is which model to choose? Which model to choose? And one view you can take, I mean, I'm an engineer, right? So I would argue that we can take both of them. We don't need to abandon either of them. But then we have this bell curve here. I mean, this is a very illustrative diagram here. It's not literal. You have experience on the x-axis and frequency on the y-axis. And I mean, let's say you have a distribution like this. It's a hypothetical illustrative description of experience. The argument is that the model M probably is going to explain, hopefully, even that people will question, but let's, for the sake of argument, say that it's very successful. And I think it is successful to a large extent in explaining everyday experiences, the middle portion of the bell curve, right? The taste of tea, the smell of a rose, you're hearing some melody, pain, memory, even maybe meditation and stuff like that, right? Model M. Now, on either sides of the outlier regions in the bell curve is where model C comes into play. Rare experiences and very rare experiences. I've just put some list here. I mean, this list is not at all exhaustive. You have transcendental states, yogic samadhis, mystical experiences, out-of-body experiences, psychedelic experiences on one side. And I mean, I've just put them on two sides here, really. Near-death experiences, mediumships, clairvoyance, reincarnation, etc., etc., etc. The reason that they're on the extremes is because they're very rare, right? They're rare or very rare. And model M has a problem with those. Clearly, it has a problem with those, and I'll show you why it has a problem with those. But both models have a regime to play. Actually, both models have a role to play in some sense. Now, coming to the outlier experiences, right? What is interesting is that one distinction between model M and model C is the following: that in model M, the brain states or brain activity is directly correlated with experience, whereas in the outlier experiences, at least in some of them, there's an inverse relationship. That means that certain experiences are accompanied by reduction in brain activity. That is the counterintuitive part. There's a whole bunch of list of examples in this very nice paper by Bernardo Kastrup in 2017. There's a whole bunch of experiences he talks about, but I'll just talk about one experience because even Arnold talked about mediums. I thought this example is interesting. Psychography, right? So psychography is this interesting thing where a medium enters a trance state, and they claim that they get some messages from the other world. Maybe a spirit enters them or whatever. Or they're a channel of information from another world, and they write stuff. That's called psychography. There's a writing here. Now, there's a neuroimaging study in 2012 by Perez and others. What they showed is that when the mediums are writing, when they're writing it in the trance state, they found that the temporal and certain aspects of the brain and even the hippocampus, it showed reduced brain activity. Very strange, right? Whereas when they were not in trance, it actually showed normal activity. But when in trance, when they're writing, it showed reduced activity. Temporal lobe and hippocampus and other, and these areas are responsible for language comprehension and and even for certain skills of language and writing and all that. And when the text was actually analyzed, it was found that in the trance state, the complexity of the test was much higher. So there is this inverse relationship, that the brain activity is reduced, but the output that they generate is much more rich and much more complex and much more lucid. It's not just garbage or rubbish. What they write is very complex. So how do you explain this strange inverse relationship? The other classic thing is strange experiences, right? Pun intended here, Dr. Strange. So of course the near-death experience, right? So I think this is something that is again considered to be very, very controversial in many circles, right? It's about a set of experiences which are usually people with, say, cardiac arrest or other kinds of it could also be during meditation also is possible, wherein they have this awareness of being dead. They have an out-of-body experience. They claim to be flying above the hospital table in the ICU. They move through a tunnel. They merge in some all-encompassing love and light, all kinds of things. They meet relatives, life review, etc., etc., etc. I mean, there's amazing stuff they write about. Now, what is very interesting is that this has been taken very seriously in the last, I don't know, maybe 30, 40 years or even more than that. And there are lots of scientific study of this. There are well-designed, scientifically designed, even prospective clinical studies, prospective longitudinal studies done on them. I'm just giving you a few references here. And what is common in most of these studies is the following, right? Okay, first of all, they're rare. They don't happen. That's why they're outlier experiences. But what is interesting is that normal physiological, pharmacological, psychological, and demographic explanations are not possible. I mean, there's really no explanation to be able to explain the data here. That model actually fails to explain. And I'm just quoting here Penny Sartori. Penny Sartori was a nurse in a British hospital, and she worked for 17 years in an ICU. And eventually, she wrote actually a book on NDEs. And she says the following: according to mainstream science, it is quite impossible to find a scientific explanation for the NDE as long as we believe that consciousness is only a side effect of a functioning brain. So this is like an interesting point, right? That's where the model C actually comes in, right? The model M is not able to explain, because remember, in many of these cases, there is clinical death, and EEG is flatlined, ECG is flatlined, and still they have these amazing experiences. I thought I'll share two lines of data here, which is actually the most challenging for Model M. The two data here is one of them is NDs with veridical perceptions. So basically here, I'll give an example that's probably illustrative. Pim van Lommel, in Netherlands, he's a Dutch cardiologist. He talks about an experience, talks about a case that he came across. So there was this patient who comes to the who has a cardiac arrest, and he comes to the hospital, and he enters a coma, and he's on respirator for a week. After he wakes up, he actually says that a particular nurse had removed his dentures. He was wearing dentures, and that particular nurse had removed the dentures. And not only that, he actually talks about how the surgeons and the nurses were trying to all the efforts that they were doing for his resuscitation. He actually describes all those events. Remember, he's in a coma all this while. Okay, he's in a coma all this while, and they're all verified. They're all verified. So these are actually called veridical perceptions, right? There are perceptions which is not possible because the brain is almost. I mean, it's you can say it's dead. For all practical purposes, it's not functioning. How is it that this data is available for this person to say something and that being verified? No, one might argue that, okay, maybe the brain is gasping for oxygen. I mean, there could be some kind of an explanation that you can make, but the other set of data is even more interesting, which is called the shared NDE. Now, a shared NDE is a very peculiar experience. It's about an experience by a healthy bystander. So it could be a nurse or a doctor or a relative who's perfectly healthy and normal. He or she has no problems. They're not under any medication, or they don't have any problems. They have the experience with the dying person has. That's called a shared death experience. This is very crazy, right? I mean, you can't explain it using the brain of the dying person here, because the experience is happening to a healthy bystander. So now this I've given these two books here. The Irreducible Mind is a classic. It's an 800-page volume encyclopedia, you can say, of all kinds of experiences. Now, the 2016 book is more recent by Rivas and co-authors, where they give more than 100 examples of veridical perceptions. Okay, so that's I thought I'll just lay it here. Now, what is interesting is that if you look at the trends of scientific theories in consciousness, which is my field of study, there are a number of theories. There are all kinds of theories there. There are a few theories which are more resonating with Model C, the consciousness-centric model. I just listed a few here. Hoffman's conscious realism. Tonini's integrated information theory is sort of in between. You can say it's in between Model C and Model M. It's not straightforward. Bernardo Kastrup also proposes a metaphysical idealism, and he talks about the role of dissociative disorders or the nature of dissociation happening in universal consciousness as a mechanism to explain all the inverse relationship between brain activity and self-transcendence. But what is important to remember is that all of these, or more or less all of them, will agree that consciousness is fundamental prior to space, time, and matter. That's the biggest difference between these theories and other neuroscientific theories, right? Because for other neuroscientific theories, space and time is fundamental. Now, the question to ask is, what do the physicists say? Is there any other line of inquiry that we can make? And yes, there is. And you'll be surprised to know that space-time is actually doomed. And I'm not saying this, leading physicists are saying this, that space-time is not really the right primitive for any fundamental theory to be built upon. It's okay as a model, it's okay as an approximation, but it's not really the right fundamental primitive. Gravity and quantum mechanics has served a death knell to space-time, and anything below Planck's dimensions, space and time have no meaning actually. and this is called the new revolution, and very prominent scientists are actually saying this. The other line of argument is from biology. This is again Donald Huffman's argument that there is no reason to believe that space and time are the right attributes of reality. They're just useful fictions which a species creates from evolutionary pressures by natural selection in order for survival. It's not for the space and time are not really out there in reality, but there's useful fictions which help in optimizing fitness. That's the argument that he makes. It's a very nice set of arguments he makes using evolutionary game theory and natural selection and examples he gives. And he says that there's no reason to believe that the Homo sapiens, that we species, we look at the world and we look at space-time and we believe that is actually fundamental to reality. There's no reason to believe that. It's just an evolutionary adaptation. And last but not the least, I think, as I said earlier, if you remember the experiment that we did, we didn't have the time to go into detail, but space and time is already a model of perception. It is not part of the data. It's not part of the data, actually. It's the data is all, the only data that you have is thoughts, feelings, sensations, and perceptions, and the feeling of I, Now, space and time are superimposed on that as a model. They're superimposed on that as a model, and this is the insight from the Upanishads, because if you look at the Mandukya Upanishad, this is exactly the point that they're talking about, that the waking space-time is not a good reference frame. You have to have you need to stand at an equal distance from the waking, dreaming, and the deep sleep. Of course, Upanishad also talks about Turiya, which is not really a state, which is the background of all these three. But the argument here is that the Upanishads have rightly looked at it in a very scientific manner, because the frame of reference should not be the waking state space-time. That's the argument that I'm trying to make here. And all these three lines of argument, physics, biology, and experience, are converging to that point that it's not a good idea to take the waking state space-time as fundamental. And this is just a thing I thought I'll show here. If you have the time, you can look it up. It's a wonderful talk by a very distinguished physicist Nima Arkani Hamed. He talks about why space-time must dissolve into more fundamental structures. He gives you the physics side of things, in a very detailed manner. Yeah, so this is something that one could look at. So now let me come to the last part of my talk, the consciousness AI edge of the triangle. I think many of you are familiar with this particular humanoid robot called Sophia. In 2016, it was invented by Hanson Robotics, a Hong Kong-based company, and it became very popular. And in 2017, Saudi Arabia gave it citizenship. I mean, that's interesting, right? It's almost like recognizing it as a citizen, as a person. And Sophia is built on all the AI methods. It uses face recognition, emotion recognition, deep neural networks. I mean, it uses all the AI techniques. But the question is, why is this conscious? I mean, is this conscious? Because if it's going to be given citizenship, obviously it has free will and intention, and it's a person, right? I mean, that's what the implication is if you hand over citizenship to it. But what about these? I'm just giving you two examples here. I mean, I'm pretty sure that none of you here will agree that, will even believe that the mannequin on the left and the ventriloquist puppet is conscious, right? There's no way that you will believe that. What is different in Sophia that is different than these two here? And my claim is that really there's no difference between the two. And this argument can be made very strongly. It's actually made in, it's a very nice work by John Searle, the philosopher John Searle in 1980. He comes up with what is called the Chinese room argument. It's a very simple argument. The argument is as follows. There is a person inside a room who does not know Chinese. The person inside the room does not know Chinese, but he's given a book, a huge dictionary or a huge book, which tells him how to manipulate Chinese symbols. Okay, it's a sophisticated set of rules. And on one side of the room, a person gives a question to this person in the room in Chinese. This person does not understand Chinese, but he knows how to manipulate the symbols using this dictionary. And he gives the answer in Chinese again to the person on the right. Now, for people outside the room, they will believe that, I mean, they're led to believe that the person inside the room understands Chinese. But the person in the room does not understand Chinese. And this argument that is given that computer is nothing but this Chinese room, the computer or the Sophia is just manipulating symbols. Or think of it this way, that the programmers in Hanson Robotics, they're like the ventriloquist. And they have thrown their knowledge into Sophia, right? And the Sophia is a puppet. It's just a fancy puppet, that's all, So AI is like this. Now the question obviously is, what is it that makes us believe that this person inside this room does not understand Chinese? So in other words, what is central to intelligence? And the answer is that following instructions, manipulating symbols, which what a computer does, is not equal to understanding. That's what the Chinese room argument is saying. And understanding is necessary to be qualified for intelligence, right? If you memorize something and tell me, I don't believe that you understand it, right? I will ask you, explain it to me, right? That's why we sort of frown upon people who memorize, right? Now, understanding is a conscious experience. That's the beauty of it, right? Understanding is actually mysterious. If you ask me, how does understanding happen? We really don't know how it really happens, So, and that consciousness is central to intelligence. And David Chalmers also makes this point that this is how consciousness comes into the picture, that when you talk about AI and you talk about giving it intentionality, we can't avoid consciousness. So consciousness is really at the center of the things. So summarizing, just very, very briefly summarizing, the AI brain linkage, the main question to ask is, what is the way ahead, right? And the argument that I'm making here is that we're nowhere near to the brain in complexity, architecture, performance, and carbon footprint. And I think our future should be, how can we have a sustainable model of AI? And maybe that's where we need to learn from the brain. How is the brain able to do it with so little power consumption and so much of noise inside the brain? It's still able to do an amazing job, right? So I think that's the future line of direction. And in NIAS, our research group is taken a baby step, you can say, towards this. We have proposed a model which is brain inspired. It's still a baby step. The brain consciousness, you have the two models, model M and model C. Does consciousness depend on the brain or not? This is again the billion-dollar question, right? And we don't know which is, maybe both are required. And the last but not the least, how do we understand understanding? How do we understand understanding? So going forward, as I said, I think consciousness is the key in this triangle, in this trinity, and understanding consciousness. And that's why I think the symposiums and webinars like these are very important, because the nature of consciousness, the concepts of consciousness, what are important. So I'm going to just list out some stuff here. I'm not going to go in any great detail here. But I think the point I'm trying to make here is that I think what Dr. Alan Wallace did in the first day, very lucidly he did this, right? That the scientific method, you have to be very rigorous. And the argument here is that all models are wrong. These are all like, famous principles of science, right? All models are wrong. There are fundamental limits to knowing. Experience is the datum that we have. Space-time matter is a model, okay? And data is the king. I mean, these are the kind of things. So the point is that we must be open and humble. And that's what Dr. Wallace also said, that we need to be able to acknowledge new data which can challenge our models, including model C as well and other models, And I think that model C is now slowly, model C and its variations, I'll just give you one model where consciousness is at the center, at the foundation, but it has amazing ethical implications. How we deal with each other, how we treat each other, how we deal with nature, how we build AIs, right? We will not build AI which will burn the earth, right? I mean, if we have model C in mind, actually. But model M is still useful, remember, okay? I'm not, all the work that has happened, the material model is important. We cannot throw it away. It has led to where we are today. And last but not the least, I think Indian philosophical systems have a lot to offer, but I don't have the time and I'm not really an expert on this. And I think there are wonderful speakers who spoke about it in this symposium. But I think I'll end with what Dr. Alan Wallace said. I really like what he said, that India holds many keys for saving humanity. And I think there are several lectures in this symposium and in this whole conference that the Upanishads, the Buddhist tradition, I mean, all the Indic traditions, how it can offer. So I just want to conclude some references which you can maybe see offline. And thank you very much, Professor Bindu and Dr. Ravindra, for this opportunity for me to share my thoughts. And that I conclude my presentation. Thank you.
Thank you, Dr. Nitin, for that very lucid presentation. I mean, your talk re-emphasized that the concept of consciousness is also, I mean, very puzzling. You can look at consciousness from various perspectives. That's what you have done from using two models, model M and model C, and using the AI brain interface, AI consciousness brain interface. Very, very interesting talk. Did you test this in the, these models? Anyway, we will take up this discussion later. So mind-boggling talk, actually, very nice. But you have simplified it and given a very nice presentation. So we will now move on to the next. Next presentation is from myself. Wait. I will Just go back to our previous. I will just talk first. So I was supposed to give a talk on brain dynamicity and meditation proficiency. But now, yesterday, while preparing for the talk, we were thinking, why should we give a talk on that? Anyway, we have to, three speakers already have discussed at length about various aspects of meditation and its relation to brain plasticity, consciousness. So I thought I will just share with you our journey, that we started almost 20 years back, and in understanding the neural perspective of consciousness. So I thought I will just share this experience and little bit about NIMHANS, because this this webinar is from NIMHANS, so all the participants also should know about NIMHANS. So this is a journey through
Hello, we can't hear you. Hello. Okay, I think there is a disruption, and I think they will be soon online, I think, yeah. Yeah, I just heard from NIMHANS that they're going to restart the. Oh, okay. I think they're up there. Yeah. Okay. Yeah.
Yeah.
Over to you.
Sorry for that technical glitches. Welcome back to the session, and I will just wind up within maybe within 10 minutes. Just starting the journey from the journey of NIMHANS itself. NIMHANS has got more than 150 years of rich history. It started as a mental asylum or lunatic asylum in 1847 during the colonial era, and in 1925, just take it down. And 25, the asylum was rechristened as the mental hospital. And in 1954, we have got an All India Institute of Mental Health. And the founder director of AIMH was Dr. Govindaswamy. And he was a great visionary, and he wanted to start a multidisciplinary approach for integrating mental health and neuroscience and towards studying human behavior. And in 1974, AIMH and the mental hospital were amalgamated and giving birth to the National Institute of Mental Health and Neurosciences, NIMHANS. And this is the NIMHANS logo. With the swan depicting the mind of human being. And this is conceived by Dr. Govindaswamy, the founder director of AIMH. And the meaning is, I'll just read out: in the depth of the heavens, the moon sails shedding splendor, that is a benediction. Below, on the troubled waters of life, moves the mind of a man, swan-like. So that is the insignia, the logo of NIMHANS. Nearby is the lotus heart, passion-laden and just blossoming. Hidden in the wombs of water lies peace, born of harmony, and to be realized by one who has subdued passion. So this is a very realistic in today's consciousness webinar. That is why I thought I'll just share this information. So the smooth gliding of the swan is analogous to the psyche. The webbed feet of the swan, immersed in water, are, however, in a frenzied turmoil as several factors in the depth of the psyche. But one can get solace if of peace and harmony, if who has subdued passion. And also, I don't want to miss this opportunity to show the picturesque landscape of NIMHANS, which is sprawled over more than 100 acres. And the CCS is situated in this building. This is one of the ancient buildings of NIMHANS. This is now the administrative block. So we have the Department of Neurophysiology and the CCS in this building. And she is Professor Pradima Murthy. She is our current director. She is a psychiatrist by profession. And NIMHANS has a rich history on consciousness studies. NIMHANS, by the virtue of its indisputable competence in neuroscience and mind science, had recognized the importance of initiating and perpetuating studies to explore the interaction of brain, mind, and consciousness, because it is being one of the premier institute of for mental health and neurosciences. And so the studies on brain, mind, consciousness have been started from the very beginning by renowned scientists and visionaries of yesteryears, like late Professor Desiraju, Professor R.M. Verma, and Professor Kapoor, and many other scientists who initiated many dialogues on brain, mind, self, and consciousness. And that culminated in getting a project consciousness by a major funding agency of India, Indian Council of Medical Research. And it went on for almost more than 10 years. And so the project consciousness has been initiated in the Department of Neurophysiology by the then head of the Department of Neurophysiology, Professor Desiraju, who was a well-known a world-renowned neurophysiologist who has contributed in understanding the thalamocortical mechanism during sleep and wake. And his team, Dr. Kanjan, Dr. Meti, and Dr. Shirley Tellis, they have initiated studies, and their studies have been also globally well recognized. Up to, and they, now Dr. Shirley Tellis is now the director of Patanjali Research Foundation, Haridwar. So the journey of the present in the team of neurophysiology headed by me have initiated studies in 2000, imbibing all these inspiration from the SREL professors and to continue the research studies that have been already initiated by Professor Desiraju. We have started the studies on consciousness. Mainly our idea was to understand consciousness, especially neural correlates of consciousness, from an illness to wellness spectrum. So we have undertaken studies from illness perspective, especially from neurophysiology studies, to study the neurobiology of schizophrenia, cerebral ataxia, Parkinson's disease, and generalized anxiety disorders. And these from a sleeping brain perspective. So we have conducted many studies, many sleep studies to understand the fundamental problems associated with these neuropsychiatric disorders. In addition, we have also initiated studies on meditation, especially meditation and sleep organization, meditation and cognition, meditation and well-being. And so you see that we have undertaken many studies from illness to wellness spectrum and to look at the neural perspectives of consciousness. And this was the team earlier, but earlier team means we have also, our present team is also there, including Saket. So this has been taken, I think, very recently, maybe in 2017. And I'll just go through our main studies. From the perspective of sleep studies on disorders of consciousness, we have carried out studies in patients with schizophrenia, and we have demonstrated many various aspects of sleep instability, and also various other, how sleep is related to the symptoms of schizophrenia. And in cerebral ataxia, what are the sleep abnormalities associated with the sleep? And we were not able to, due to these abnormalities, we were also not able to even study the REM sleep stages properly. Assessment of sleep spindle density among these patients. So we have observed in general there is a deficiency of sleep spindle characteristics, and that is very important for the initiation, for the maintenance of sleep. And that is the determinant of the quality of sleep. We have also observed that treatment, Ayurvedic intervention studies, helps to preserve sleep as well as promote sleep continuity in patients with generalized anxiety. So these studies have given us a lot of impetus in understanding the neurobiology of these various disorders and various disorders. And then when we have moved to understanding the sleep structure, sleep organization using meditation studies, we have found that, one important aspect of human sleep is that human has got a very stable architecture. But now how meditation, like Vipassana meditation, can alter this structure or can bring a proper sleep organization. That was our interest, and we have studied sleep organization exclusively using Vipassana meditation, and we have observed that meditation proficiency enhances, helps to establish proper sleep organization with enhanced REM sleep state and enhanced slower sleep states. And also this meditation practice helps to retain proper sleep organization even in aging. So there is no compromise. Usually age-associated compromises in sleep quality we usually see, but meditation practices help to retain a proper sleep organization. And in addition, we have also studied at length the REM sleep organization and how it is that can be correlated with the neural plasticity events associated with the meditation practice. We have carried out many studies. And in addition, we have initially studied the sleep organization among meditation practitioners. Now we are moving on to some other directions like understanding the lucid dreamings, understanding the neurophenomenology of dreams in particular, in general, and lucid dreams in particular. So these studies are going on now. In addition, we have also moved into other areas like meditation proficiency and brain dynamicity, mainly brain dynamicity and brain experiences associated with the meditation practice, task performance, meditation proficiency, how meditation proficiency lead to progress in well-being studies, importance of meditation tradition, in achieving wellness. So we have also initiated studies using meditation, Vipassana meditation, Brahmakumari's Raja Yoga meditation, heartfulness meditation, Isha Yoga meditation. So how this traditional meditation practice, how do they differ each other, but still how they are converging to realize that, to see that how each meditation tradition is so important in enhancing wellness, in enhancing well-being, and also how they bring these changes, the brain activity changes as well as the mental changes in a different way, but ultimately that converge upon enhancing the meta-awareness. So we have got a lot of, we have initiated a lot of studies to see that, for example, in Vipassana meditation, it is in mindfulness meditation, they use multiple meditation techniques like Anapana, Vipassana, and Metta Bhavana. So these are all cognitively intense as well as emotionally intense meditation state. So different experiences, how brain, how we can dissociate these different EEG changes associated with the different meditation techniques we were able to study. We were also able to study how meditation proficiency help in shifting states from a rest state to meditation state, along with accompanied with a concomitant change in the brain activity using Brahmakumari's meditation tradition. We have also observed, carried out studies to see the state trait influence even on cognitive task performance, how that changes the EEG brain dynamics. How to study both the state trait influences, and also we have also used other meditation tradition like heartfulness meditation. Heartfulness meditation is a totally different aspect of meditation tradition where it is a kind of passive meditation. So the meditator only focuses his attention to the heart, and he just imagined the transmission from the guru. So it is a kind of passive transmission, but still we have observed quite a lot of changes, and also meditation proficiency, how it enhances well-being among these tradition. And also we have demonstrated that how meditation proficiency is important to enhance well-being using a large cohort of more than 1,000 participants, and using various the well-being questionnaires developed by the Research Foundation of Raja Yoga Brahmakumaris. So here we realize that the importance of developing questionnaires based on the tradition. So in addition, we have used, in addition to the conventional psychometric questionnaires to analyze well-being, it is very important to develop questionnaires from the perspective of a tradition itself. So we have initiated these studies to have the scales from the tradition itself. So in the last 15-20 years of our research, studies have culminated in the establishment of a multidisciplinary Center for Consciousness Studies in the Department of Neurophysiology, established in 2020 with a vision to become a global center of excellence in consciousness studies, and with a mission to undertake to build a platform for multidisciplinary research in the domains of science, humanities, and culture pertaining to consciousness by integrating Indian philosophical wisdom with that of neuroscience. These are the current staff working. Ravindra, Arun Ramjayam, And currently we have 5 scholars, and they are all working on different aspects of understanding consciousness from different perspectives. Wilson studying on neurophysiology and phenomenology of dreams, neurophysiology of meditation, brain oscillation and cognition, and various aspects. So the objectives of the center now currently are to take up studies on neurobiology of sleep, dream, and consciousness. We have initiated various studies, but we have to also initiate this self in deep sleep from both perspectives, from the philosophy as well as from neuroscientific perspectives. That anyway, we have initiated some collaboration with other universities. Another objective is neurobiology of meditation, cognition, and consciousness. Continue with whatever we have been doing, and also to initiate various studies like Buddhist meditation and consciousness. Now, since we have carried out many studies on brain and consciousness, cognition, we have to look at design studies to understand the relationship between meditation and consciousness, meditation, cognition, and consciousness. So it is our endeavor to design various studies to undertake these, to meet these objectives. Other important area we have to study is, our objective is neuroscience of yogic science, culture, and consciousness. Especially, we wanted to explore well-being in the context of mental equanimity, to develop and validate tradition-based well-being scales, as I have mentioned, for each meditation techniques. These studies have been already initiated by Dr. Ramjayam. Then Arun is into understanding the disorders of consciousness from neuroscience perspective, dysfunctional to understand dysfunctional mechanism, underlying cognitive deficits, and how how the sense of self and consciousness are compromised in mental illnesses, especially from the perspective of schizophrenia. And definitely we have to develop various techniques for that we have to initiate industry academia collaborations for newer interventions as well as strategies. Another objective is neurophilosophy and consciousness. So that is what we have initiated, this multidisciplinary Center for Consciousness Studies, so that consciousness can be studied from different perspectives. So here, to undertake neurophilosophical research to comprehend the state, to understand the states of consciousness and well-being, integrating Indian philosophy, psychology, and neuroscience. We have also initiated a few collaboration with University, Cambridge University, UK, with Srivas Chennu, just to look at the brain network analysis. These are in progress. We are also now having, our MOU with Stephen Loris is in the process of getting approval from the GB NIMHANS. We have also submitted the MOU between Vivekananda Center for Consciousness Studies. This is mainly to look at the perspective of Indian philosophy and how to bridge the gap in our understanding from philosophy as well as neuroscience perspective. And so that is how we have initiated. So now to just get wider popularity of the center, we thought this webinar definitely will help us to get this wider perspective, wider popularity, and also now we are in touch with many stalwarts who are working in this area of consciousness. So the idea of starting this webinar is to have some dialogue with the speakers and to initiate some collaborative research studies on consciousness. So thank you so much for the patient listening, and we will get back now to our discussion. Thank you. Yeah. So shall we now look at the questions and let us have some discussion on whatever we have been discussing? Now, what are the questions? Can you please read out?
No, people are still posted.
Okay, let us wait. Yeah. So I would like to start discussing first with Arno. So what is your take-home message on your studies is consciousness within the brain? Because you have done elegant studies like mind wandering, neurofeedback, and other approaches like intuition. So definitely this is very convincing that we can look at consciousness from the perspective of brain and neuroscience. Even though philosophers say that we neuroscientists talk, or consider our experience and awareness as consciousness. So shall we start this discussion, Arno?
Sure, yeah.
Very interesting observation you have got from mind wandering and all, So just share with us these.
Yeah, I think you're right, but like, for example, mind wandering and these kind of questions, before people started to study this, it was just thought to be philosophy. It couldn't possibly be studied. So there is definitely yes, some interesting directions in this. Now, there, I do think, it's a question whether you have to, everything can be studied or not. Like, for example, if consciousness is non-causal, in a sense, it's like you're an observer, you just observe whatever happens, you just feel you have influence on the world, and it's going to be very hard to study because
yes.
I mean, we're studying measures. So if you can't measure it, it's going to be very hard. I personally don't think consciousness is non-causal because, based on all the models that Dr. Nagaraj showed and others, consciousness, I mean, at least in my model, the hypothesis in consciousness is part of the fabric of the universe. And if it's part of the fabric of the universe, you look at the theories of physics and, all the fundamental force, time and space all collapse during the Big Bang. So consciousness collapsed with the other force during the Big Bang. And if it does, it means there is a link, somehow at high energy between consciousness, time, space, matter, and all the fields. So in that sense, it must have a causal nature because it is connected to the other fields. So I personally don't believe that consciousness is, I don't believe in dualism. Dualism is Descartes' dualism is like there's two realms, physics and mental realm, and they're dissociated somehow. I believe it's all one realm. So I do believe there's hope, that we can study these questions, because I personally, my hypothesis is that consciousness has, maybe small, but, potential causal influence in the world. And so it can be studied. If it has no causal influence, it cannot be studied because, it can't be measured.
Yeah, very nice, because only we need to have very elegant designs to look at consciousness from neuroscience perspective. So now let us take some questions. This is to whom?
Arno.
Arno, the first question is to you. Are there major differences in different types of meditation, or more or less they are similar? And are the findings significant enough to have a serious lookout?
Yeah, so on the different meditation, are they more similar? I don't think we can answer that question, more similar or more different. It depends, because you can observe a small difference in the brain, but because of the way you record the data, you know, it might be something big in the brain. So it's not because the amplitude is small on the curve, that means that the difference is small. So I don't think we can necessarily make this kind of inference. My approach to this is, you know, the different meditations, there are different paths to realization. And what I see as realization is more consciousness free of the you know, of all the emotions, etc., free from the brain. It's like pure consciousness in some sense. It's like purified field of consciousness. And so the path to realization can take, you know, you can do this meditation or you can do this meditation. And some people will prefer this one because you know, they're more intellectual, and some will like the devotion path, and some people, like me, I prefer, like my meditation is more Zen because there's no conceptualization. So for people who are intellectual, you know, scientists who like to think, you want a meditation where you can't think it through because it's not possible to think it through. Anyway, so there's different paths, and you know, they might all lead to the same goal. And so it's not because you have differences in brain correlates that necessarily means that one meditation is better than the other. Yeah, so that's the take-home message. But what was interesting is that we still observe that there were common changes, brain changes associated with meditation. I think that's what we need to remember. There'll be differences for sure, because one is visualization of objects. Like if you look at we didn't study it, but the Tibetan tradition, they just visualize deities and so visualization. And then Vipassana is more a body scan, so it's different sensory modalities. So there's obviously going to be a difference when you do that hours every day.
Yeah, I think I will also add something on this. For example, we have got many, I look at like this, we have very many traditions, different techniques of meditation. So we have got many choices, actually. Various choices you have now in front of you. And the purpose of meditation definitely is to come up with, to attain a perfect body-mind harmony, and to come up with a very psychological as well as physical efficacy. So you are in that journey, you are becoming a totally different person with the capability to have, manifest many virtues. Like if you proficiently practice, definitely you become, your individual consciousness is totally changing, transforming to, yesterday, as Elora said, the supra-mentalism. You are becoming, a person with a compassionate mind, or a generous mind, or an altruistic attitude. And the studies have also showed that these are possible, and these are accompanied with some changes in the matter, in brain activity, brain dynamics. Different techniques definitely influence your brain and mind in a different level and different way. But ultimately, definitely it is bringing this body-mind harmony. So ultimate aim we are achieving through different ways of, influencing your brain, mind, and body functions. Now, shall we move on to the second question? And then shall I read out?
No, he wants to add.
I just wanted to add something.
Okay.
Very rich discussion. I think I completely agree with Arnaud regarding the causality part. So one debate is whether consciousness is related to brain causal activity or brain causal capacity. That is, it's not really activity, but the capacity of brain networks to be active or not. And this is actually an interesting debate, because it's possible that the activity is not there, but the capacity to act is there. And this goes back to and one line of work which Tononi does in IIT is something similar. He's talking about capacity instead of activity. And if you look at Kashmir Shaivism, Abhinav Gupta's model of consciousness, he talks about Kriya Shakti. There, it's about the causal power of the of the subjective self. I mean, that contributes to subjectivity, the causal power. That's why it's called Shakti, So there is this trying to link between capacity versus activity, this debate is there. I mean, I don't know. I'm just throwing these ideas out there. If it's interesting, Yeah.
Yeah, but the activity should be there to have that, to, possess that capacity.
I mean, Professor Bindu, think of it this way, like the heart, for example, right? The same thing is true there also, right? It should have the ability to respond to stimuli. It may not respond. I mean, normally it's just as it is, but a pathological heart will not have the degree of freedom, Something similar to the brain as well, I feel that it should have the ability to respond, Otherwise, I don't know whether the activity should always be there, I mean, I'm not sure. You should need the ability to respond, no? You think? I don't know. I mean, there's something that you probably know better than me. I'm just raising it up,
Yeah, that is true actually. But now if you consider only healthy people, we are not thinking about the disease. If you consider healthy, also definitely ability to,
I mean, the flexibility, because yoga is that, no, it's about the flexibility of activity, right? It's not just activity, but ability to withdraw and be able to have that activity or not. That's actually a capacity, right? That's actually a capacity, I think, rather than saying it as just activity, because activity can be just autonomous and spontaneous. Whereas yoga is all about having that ability to control it, right?
Yeah.
So I think that also probably comes in. I don't know. I mean,
yeah. But still, sometime, there are studies, earlier studies to show that whether mind matters, it is not the matter that matters. So they can even bypass this matter and even achieve those higher mental attributes.
Right.
So, I mean, if you go into the details of these, definitely that leads to many discussions. These are all, we will have to study these in detail in our future studies. So shall we move on to the second question?
Sure, yeah.
Which one is the second? This is can you explain dissociation in context of meditation? What is actually happening in the brain? Is it adaptive or maladaptive? Since it can also be a symptom of a disorder or due to taking certain drugs. I think both of you can try to explain this or this.
Yeah, I can comment on that. I mean, it is true that, when you do questionnaires on meditators, they tend to score higher on dissociative scales, which are clinical scales associated with mental, illnesses. And so I do think, if you're not careful and you do the wrong meditation, you can become dissociative in the sense that, you don't relate to the world in the way you should relate. So there are some risk, and I don't think they should be ignored. Meditation is like, powerful method to alter, change your brain and yourself. And so, it will be good most of the time, but it won't be good sometimes. It's like if you have a fast car, you're probably going to go faster. But if your child is driving the car, it's driving around on the wall. So if you're not prepared for the change, you can hurt yourself potentially. And in the US, there is support groups for meditators, people who meditate who experience this kind of crisis. And also, I'm not a meditation teacher, but I think in most tradition, people will acknowledge also that there's ups and downs. So you can be in the bottom where you're like dissociated, etc. You're not doing well, but it's just transient. So it's part of the path. So I don't think we can also say that, if you can't get out, but you probably need to get help to get out of this trough and then go back on the path.
Anybody can explain? Anyone want to contribute? Anybody? We can give a lot of examples, but due to paucity of time, we will move on to the other question. This is to Nitin. Is it possible to differentiate a real smart AI which mimics consciousness?
Is it possible to distinguish? That's the question.
Differentiate a real smart artificial intelligence which mimics consciousness.
Yeah, I mean, this is actually the classic Turing test, right? In some sense. I mean, Turing test is for intelligence, but you're asking for consciousness. See, the problem is we have to first agree on some definition of consciousness, right? Some model or some definition. Is it behavior based? Is it based on how the things are processed internally? I mean, so I think the definitions are very important to begin the discussion itself, right? Because I talked about understanding, if you recall, no? And to me, I think I wouldn't, the problem in today's AI is we use a lot of words, intelligence, learning, understanding, but these words are used very loosely, I would say. It's just information processing or manipulation of symbols, But is there understanding is the question to ask. And I really don't know. I mean, for example, let's say I tell you a joke and you laugh. I know that you understood the joke, right? But is it just the behavior? Is it more, there are other cues here? Or, I mean, it's very difficult to say, whether somebody has understood something, right? I mean, that's why all the exams are there, right? Exams are there to distinguish between a person who does not just memorize, but understands the material, right? So when you say a smart AI, I think the challenge is still the same, right? We need to figure out a way to model or test understanding. Ultimately, it all boils down to that, and how do you do that? I mean, I think we're far away from that,
Yeah, I want to mention something too. I actually do lots of work with deep learning on brainwaves, and but I like to propose a new Turing test, and the Turing test would be if you can feel one with the other, could be AI, could be an animal, it can be human, then you can assume that entity is conscious. Like, for example, a mother and her baby, she doesn't feel necessarily separate, and mystic when sometimes we don't feel separate from objects, etc. So that's like how I like to define maybe a new Turing test. If you can have that experience with an AI, then you can conclude the AI is conscious.
Very interesting.
Yeah.
So like dissociation, right? You're talking about some kind of dissociated state. Basically.
Yeah.
So the last question is very interesting. Are not all measurements by neuroscience dealing with the activities of the mind as reflected by the brain? So it is not actually measuring consciousness.
No, it's measuring the brain.
Yes.
And yeah, I mean, that's the whole question, is consciousness within the brain? And consciousness definitely has something to do with the brain. That is the content of consciousness. My hypothesis that I work on in my research is that it's just the content. It's not consciousness itself. And you can have consciousness without content. You can just be here now. You don't know who you are. You just know you are. You don't need to have any memory to be alive. And yeah, so there's no content. You're just here. And that might not rely, just on the brain. Maybe it could, be linked with some part of the brain. Maybe it's not. Also, I do think we have to revise this model, of the brain as just inert matter. Maybe it's just the world is not dead. So, the materialist paradigm, I think, over the next century will be revised to be softened.
Yeah. See, for example, even meditation can influence brain in different ways and different levels. So sometime what happens when you measure some, for example, power spectral density, it may not be showing some changes, but you may be seeing some through psychometric analysis, you may be looking at various mental attributes, okay, wellness, you may be seeing, but that doesn't mean that, there are no change happening in the brain. We may have to design your experiment to look at some other aspects of the brain activity in terms of other nonlinear measures or other like microstates or something like that. So it's all like, how do you design and then look at. Suppose if your designing is wrong, you may get some answers, but that you cannot correlate that with. Like if changes that is happening in the mind is not accompanied by brain. And also, see, for example, you are through proficient practice of meditation, definitely you are bringing a total property change, of the brain reorganization. It is not just a change in the reorganization. The properties of the network property itself is changing. So same way, definitely, even with that, you can even bring more changes in the mental capacities. So, it may not be that proportionate. It will be out of proportion, actually. So you cannot have a 1:1 correlation between the brain activity with that of the mental. But definitely brain activity, there will be changes in the brain activity for you to see associated changes in the mental functions. So shall we wind up then? Yeah, so we are nearing now, going to be 1 o'clock. So thank you so much for this very rich interactive discussion with both of you. And thank you. Looking forward to have more and more interaction with Arnold and Nitin. Anyway, we are interacting, we are having a lot of collaboration. But now in future, we look forward to have some collaboration with Arnold, your colleagues, as well as with Antonino, so that, because the mission is to take up studies, to interact with people from different areas of research on consciousness, and to have so that we also will be able to develop some model that can integrate the philosophical perspective as well as neuroscience perspective. So we will be in touch with all of you, and thank you so much now for this wonderful session, for the great talk all of you have delivered. Thank you.
Thank you very much.
Thank you very much.
Thank you. And thank you so much, all the participants, for your active participation. And we will be now leaving. We will be having a lunch break now, and we will resume by 2:30. So see you at 2:30. Thank you so much.